Okay. Whoa, jeeves. Okay. Now, last time we did this data, we looked at the number of beers somebody had the night before, a 7 a.m. test, and then we looked at the grade that they made on that test. And what we found for this completely made-up data, here's the image. Okay, so again, if you need a calculator, we're going to do some more data here in a minute. That's what we got last time. And that line going right down the middle, what is that? Line of best fit. And what does that sort of visually here do? Why is that exactly where it is? What does it try to do with all those data points?
Draw one through the middle.
Say again?
Draw one through the middle.
Through the middle. So it's sort of like a visual average of all the positions of those data points. So this one, would you say this is kind of a weak relationship or a strong relationship? It's very weak. How do you know that? Because all the data points are pretty scattered. They're not very close to that line. Right? So the line is doing the best it can. The data is just kind of all over the place. So that means that the number that we calculate to see how strong this fit is should indicate a weak relationship, if any. And what else can you tell me about it, of course? Negative. So it should come out negative. And so what we found last time was this. Here's the important part. R is negative 0.3. That's pretty small. It should be close to negative 1 to show good negative correlation, meaning all the data points would really be close to the line. Since they're pretty scattered, it came out pretty closer to 0. It's still negative, still a down slope, but it's not very strong. How are we doing so far? Of course, if you missed the last class, yeah, I'd say go watch what you can of the video. At the very top here, we see the actual equation of that line. That's how we managed to get it into the calculator. We just plugged it into y equals, pop, and then we put in the slope and the y-intercept, and that's how I graphed that line. How are we doing so far? Okay. So, a couple of things. First thing, we got an R of negative 0.34, right? The sample size, I can't remember now, was 14. Oh, yes, ma'am.
How do I get back to that? What gives you the R?
Oh, mine was just up here on the screen since last time. But if you hit Stat, Calc, and of course that fourth one, right? It'll come up with all this here. Okay, hopefully. If it doesn't come up with R, then you need to come see me. I'm not going to go through that again. Okay. Let me see, where was I? So what we need is a way to tell, is that number really evidence that there's no correlation? Now that sounds like a hypothesis test, and there is a hypothesis test in the background. There's not going to be any hypothesis test for us for the R's. There could be if we had more time, but no. I'm just going to give you the benchmark number. And just to show you where that comes from, here's a little chart. You actually have it in your book. You have it in the little insert. I'm just going to give you the number. So for a sample size of 14, and look at, they give you a couple different levels of significance. Let's just use 5% like we normally do. For a level of for a sample size of 14, you have to have at least 0.532 R to show correlation, and we only got 0.34, whatever it was. Are you guys semi with me so far? So you're not going to have to do a hypothesis test with this R stuff, but I want you to show what's really going on behind the scenes. I still have to show evidence that there's a correlation or not. For a size of 14, I have to have an R above this. R, that's exactly like the Z, and the Z star would be like our R that we find. So this is like the benchmark, the test statistic. The critical score, and then the R that we found, the 0.34, would be what we compare it to, and that didn't get far enough away. So it wasn't evidence. So on the test, I would give you this number. So then when you calculate R, you can see very quickly, did it get above this or not? So in this case, it's not even weak correlation. Technically, there's no correlation. Are you with me so far? So any correlation I saw was really probably just because it was such a small sample, there's going to have to randomly be some correlation. Most likely it's not going to be 0, it's going to be something, but why was it negative 0.33? Just by random happenstance. That's all I can say. If I took a larger sample, maybe I could say something more, but I didn't. So too bad for me. Is everybody with me so far? So there are no more hypothesis tests in chapter 10. I'm just going to give you the number, and you just have to compare it very quickly to tell if there is. Okay. What was the other thing I was going to tell you? Oh, this line. Well, I don't want to use this one because it sucks. This is bad correlation. So let me ask you, would you trust the line to make predictions about this data? So if you said, well, what if I drank 7 beers? Would I be able to wake up? And secondly, how would I do on the test? Could you use the line of best fit to kind of predict that? Hell no. We see right here, we don't trust it. So if R was bigger than that 0.532, I'd say I trust the line to make predictions. The larger it is, the closer it is to 1 or negative 1, the more I trust it to make predictions. How are we doing so far? Y'all like, can't read you, I tell you. You should play poker. You make a lot of money. All right, so let's do this. Let's try the problem, the other problem on this paper. Tease me. This one down here, the one about number of hours studied versus grade. I did ask you to try to do this on your own. I'm not sure if anybody was able to try that out, so we'll do it right now. Do it live. So somebody, can you turn the lights out? Just the one, yeah. All right. So let's all take a second and do the exciting part of statistics, the data entry. Put these into your list 1 and list 2. And just to prevent somebody who wasn't here last time from making a major mistake, do you want to sort these at all? Hell no, because you need those numbers to go with each other. The person that studied 22 hours got a 79 on the test. You have to have those go together. If you sort them, you're mixing the X and Y parts of the points. It's no good. So do not sort this data. All right, I think hopefully we've all got it in there. Everybody's got this handout, right? So you have your own data. Okay. So I've got the data put in there. And L1 is the X's, the inputs, the number of hours studied. And L2 is the resulting grade made on the test. So now here's the steps to do this. And no, on the test you cannot bring the calculator Bible and use it. You have to know the steps. And also, what I'm going to ask you to do on the test, I'm going to have you come up to me and show me on your calculator the scatter plot with the line of best fit on it. You with me? So you have to show me that scatter plot with the line of best fit. And then I'll mark it somehow, and then I'll know that you did it. So if you don't come up and show me, you lose points on that part. You have to be able to show me that you can do that on your calculator. So how do we do this? Stat. Good. I want to calculate something now with the data that I put in. So I want to go to calc, and then it's pretty obvious which one I want to use. Number 4, because I want to get that line, and then an extra piece it gives me is that R. So in the book, 10.2 is all about the R, and 10.3 is all about the line of best fit, if I remember correctly. They kind of break it up into 2 parts. So I would do all of Chapter 10 homework at once if I were you, because it's the same data. So now if we hit number 4, linear regression, that's the stuff from before. Don't freak out. It defaults to L1 and L2, so as long as you put all your data there, it'll be there. So you hit enter. And do we all get this? Because I certainly could have put something in incorrectly. I love when I do that.
Yeah, that's right.
Thank you.
I think the R in your calculator.
Oh, real quick. For anybody who doesn't have R showing up, do this. You ready? If anybody else doesn't have R showing up, yeah. Okay, here we go. If you don't have R showing up, here's what you do. Hit second 0. This is one situation where I say, don't ask me questions, just do this. Because it's just weird. Hit this button right here to get to D. I want to get to the D part of this list of everything the calculator can do. So just hit X to the -1. That's the D section. You should go now to the D. You with me? Okay, okay. Now go down to diagnostic on. This is very intuitive. No. Diagnostic on. Right? Enter. Enter. Okay, now go back, and that's very anticlimactic like normal. Go back to stat, calc, number 4, enter, and now your R should show up. Yay! How are we doing so far? Okay?
Is that going to mess with any calculations on the calculator?
No. I think I found out 1 or 2 other things it turns on, but it's just extra information. It doesn't mess anything up.
Or just take the square root of R squared.
But R squared didn't even show up. Yeah, that's the problem, yeah. What's our line of best fit equation? Six, 5, 7, X plus 70.97 about, right? You guys good? So the A in this case is like M from algebra, slope, and the B is like B, yay, y-intercept. So let's see, would we trust this data? I mean, just even, it's a little longer list than the other one was, right? And the other one had an R of 0.532 would show evidence, and this is bigger than that one, 0.737. You guys kind of with me here? So that sounds like it should be enough evidence. It's a bigger sample, and it's even better than what was required for 14. So if I look at what's required for 19, this is 19 data points in there. For 19 data points, oh, Jeff, you got it on the computer. For 19 data points, I need an R, go away, of just 0.456. And we got 0.737, right? So that means that that's evidence that there's correlation. Are you guys with me? So a lot of statistics is all about, is it enough evidence? What you see in your sample, is it enough evidence? Because when we take a sample, it could automatically, even if we do it perfectly, we do a simple random sample, we could just happen to pick a bunch of old people. We could just happen to pick a bunch of dead cars. We could just happen to pick a bunch of whatever. So it has to have some kind of a benchmark of evidence. And we far surpassed it. So we'd say that there is a decently strong positive correlation. You guys cool with that? That kind of phrase. So if I say, what type of correlation did you find? In this problem, you'd say a decently strong positive correlation. Is that cool? Now, if it was 0.98, I'd say I found a pretty damn strong positive correlation. You can have your own choice of adjective. It's okay. All right. So here's the part that It's a little more interesting. Actually using that line of best fit. Oh, let's first actually, I got to finish this up. If you hit graph right now, it definitely sucks. I see one data point. I obviously put more in there than that, right? So somebody else already tried that, and they're like, okay, please talk about this. What do I do whenever I put new data in? Zoom 9 for zoom stat. So zoom 9, because right now it's set on where the old data was. It's not going to move until you tell it. So if I go into zoom stat, anytime I put new data in, you hit zoom 9. And it's one of the steps on the process on the Calculator Bible. Zoom 9, it'll find your data for you. Now, does that back up what we just found with the R being a decently strong positive? Isn't that a lot? It's not tight necessarily, but it's a lot tighter than that first set of data, isn't it? There's a very obviously upward trend. With me? Now, I'll be honest. I have done studies every time now. I've done studies on the number of homeworks completed by students and how it predicts their grade. Now, one thing you could ask, it would be a little bit of a cheat if I actually put the homework grade into the average that I use. Because then you say, well, of course the number of homeworks affects the grade. You're using it. So I compared the number of homeworks done by students versus their grade without homework included. And it's always a statistically significant positive correlation. The more homeworks you do, the higher grade you get. Now, does that mean that what I just said, actually, I kind of just said it in a wrong way. Does that mean the number of homeworks you do actually causes you to get a higher grade necessarily? No. It could be evidence, yeah, it could be the other way around, but it could be evidence of some third thing. You're just a good student. You're just a responsible person. So you're going to make a good grade. You do the homework, but you also read the book, and you also come to class, and all these other factors that come in. You with me? Semi with me? In class? Okay.
Correlation does not imply causation.
Exactly. So how do I get that line to show up? Beautiful. Hit the y equals. And it was 0.657. Don't forget your x variable here. Right, here's your x variable right there. 0.657x plus 70.97. And that looks exactly what I would expect, right down the center of that set of data. So I love that. That's just a visual average of those points. Okay. How are we doing so far? Is that? Yes, ma'am.
Were you y equals?
Oh, so when y equals, I put that best fit line. Remember when we did the data here? Here's the R, but right above that it told me the slope and the y-intercept for the line. So in y equals, I just put those. So it's my mx plus b formula from algebra. Who knew there's an application? Holy shit.
Would there be a reason that the y equals is not showing up?
It could be, yeah. Let me see. You have R's or something? Oh, no, this is fine. Here. Let's turn it on. There, that's weird. Oh, I see. For some reason, these are turned around. L1, L2. That's weird. You had the X is coming from L2. It should have been the other way around. So you should be good to go for now. Oh, yeah. So you've got the stat plot. It's on, but it's selected to be a box plot. So you want it to be a scatter plot. So now I've hit zoom 9. So now you just want to put in there, and the y equals, you put in the line. Yeah. Oh, it is good. So is your step one. Looks good. Yeah, actually, good.
Run? Don't run.
So the independent variable always goes on the left.
That's more that one. I know. Now if you don't move it at all, it'll be on the you'll be ready.
And whenever I just start that, it was.
Oh, because you go to your list. Oh, because you put an L3.
Well, you say I can leave it up to you.
Gotcha, because it defaults to L1. So one thing you could do is right here. You can tell it
All
right.
Always have to write L1, comma, L3.
So, just up to 3 places. One in doubt, 3 places sounds good, right? So 3 places for the art. On the day of the test, I'll come a little early. The day of the test, of course, is next Tuesday. So if you have a calculator you haven't brought to class yet, or you need to borrow one, you want to make sure it's all kind of set, I'll do that. Alright, so if you want to make sure your calculator's set, ready to go, I'll get it to that point. So, just to finish out this handout. So we got, oh, I hate this. So here, studied versus grades. Our R was, I have already forgotten, 0.73, 738. On a test, I would tell you that 0.4 or whatever it was from that chart. You're never going to have to look at the chart yourself. I'll just tell you, for this problem, R has to be at least 0.4 or whatever to show correlation. So you'll know, you just double check it. If you get 0.2, no. If you get 0.5, yes.
What if it's negative? Does it need to be higher than that?
Of course, just like z-scores and z-scores, the negative has to come from you. So if I say R's got to be greater than 0.4, it's also got to be less than negative 0.4. It's got to be closer to 1 or negative 1 than whatever number I give you. It's like, cool, it's just got to be further away than that from 0. Is this a strong correlation? It's decently strong. It's well above the 0.4 that was required, but it's still kind of far away from 1. So I'd say it's decently strong.
Where does it become strong?
It's kind of it's just like the idea of what's large, right? When they say large at the bottom of the t-score chart, what's large? I don't know, it depends on who you are. So here, if it's 0.9, it's definitely, you can say strong. If it's 0.73, you'd say it's decently strong. Anywhere in between, it's, you know, if you just say strong in this case, I'd be cool with it. What kind of correlation is it? What do you think I mean by that question? I love it. So it's decent, positive correlation. Cool. And that makes sense. You'd hope that the number of hours you study would actually have an upward effect on your grade. Yeah. The line of the best fit. I was trying to be a 6 there. Plus, what was it? So, would you trust the prediction you make with this line? And the thing to be careful about, the prediction you make only is valid within your data point. So you can't predict for 30 hours. Because that's outside of our data point. So it's sort of like if you watch somebody grow, and you say from 0 to 8 months, they grew like this. So by the time they're 20, they're going to be 80 feet tall. Holy shit. So obviously, if you go outside your data, you have no idea. It could be straight line up until here, and then it levels off, which thankfully for growth, that's what it does. Right? You guys with me? So I couldn't possibly say, well, what if I studied 30 hours? I really couldn't officially say anything about it. But what if I studied 13 hours? What grade should I expect to make? What do you think you can do with your line of best fit? What does X represent in this case? Number of hours, because that was our list 1. That was like X, Y. So this is the number of hours. And Y, of course, is the grade you make. I can't write like that. You can't write like this either. So if I want to predict for 13 hours, you just plug the damn thing in. Holy shit, there's another application from algebra. When are we going to use this? Well. So you do 0.6 by 7 times 13. And what do we get here? Plus 70.97? I get like almost an 80, right? Oops. He's doing something up there. So there you go. You just got to plug it in. Now let me show you another real cool thing. If you spend enough money on this calculator, there's the whole graph right there. You don't have to do this, but here's another way to do what we just did. If you go to second trace, to go to calc, all these things on the top are all about the graph. So if I want to calculate something on the graph, I go to second trace to get into calc. And then I do number 1, value. I want to know the value for some input. So watch this. If I want x equal to 13, it'll actually find it on the line for me, and there's the output. That kicks ass. So if I want, let's kind of do this. You guys see how 20 hours got an 85? Let's see what the prediction is. It's not perfect, is it? This line of best fit is not perfect. But let's see how close it gets to what it should be. So for 20 hours studying, I predict an 84.11. That's pretty damn close to the 85 that actually happened, right? And I expect it to be decently close because our correlation was decently strong. You guys with me? So the whole idea of would you trust this line to make a prediction, it all depends on what your R is and what the cutoff score is. So obviously the bigger your sample is, the less evidence that's required of you because the more you trust what you see. Are you with me? Okay. Let me think. Was there anything else I wanted to tell you? So section 10.2 is all about finding R and interpreting what R means. Section 10.3 is about finding the line of best fit. And then they ask you, what would you predict for 40 whatevers? And what would you predict for this? You just plug it in. Not a big deal. Now, a really good question would be, what if my line of best fit sucks? And I still want to predict, what would you make for 13 hours studying? Your best guess has always been what? What has our best guess always been? So if I had to take a best guess of a grade that anybody would make, I would take the average of those. So if you can't trust your line of best fit, you fall back to what used to be always the best guess, which is the average. But if our line of best fit works, we have a much better way than just a guess. We can actually predict what it would be for something in the middle if we trust our line. Okay, I do this a lot. Oh, last thing. Haha. I just got to show you this because I thought it was kind of nifty. Real quick. This gets kind of hyper-technical, so I want to just point out a couple things. Let me just let you read the title. It's like one of the first things that showed up this morning when I just typed in correlation between. I wanted to find some kind of journal, some kind of study that was done. And I found one that was talking about MySpace, and that was from a while back. But this one talks about frequency of Facebook use and student engagement, which is more like how engaged you are in your academics. You with me? So, real quick, right here, results indicate that Facebook use was significantly negatively predictive. That's a negative correlation with engagement score. So if you use Facebook a lot, the correlation seems to suggest that that type of person is related to a low engagement in classes. And just to show you, I mean, like I told you, this gets really technical really quickly. But just to show you something that should look familiar, here's my regression analysis. They found R squared. You see what I'm talking about? So they found R basically. They found P related to the hypothesis test that we don't have to worry about for correlation. I mean, all this stuff, you could actually, in here, Pearson's R. Remember I told you it was called the Pearson product or the correlation coefficient? So again, you could read this. It's actually decently in English and not too much in Mathish. And even understand some of this stuff here. See this R of 0.493? Considering they talk to thousands of people, that's pretty damn indicative of correlation. You with me? 0.493 is pretty damn big when you talk to thousands of people. You with me? Sort of. Okay. All right. So I just want to show you a real life example. This exists in a journal somewhere. And this is just data that you could actually calculate if I could get the data for you. You could actually do the same calculations now. All right, that's it. Thanks, guys.